All right, in case you missed it, this was today's lesson. You will find the absolute value of complex numbers, write the trig forms for complex numbers. Complex numbers in trig form. Okay, first, let's talk about the absolute value. Absolute value is defined as the distance from 0. So a complex number is written in the real and imaginary coordinate plane. There's a real part and imaginary part. The real part is on the x-axis and the imaginary part is on the y-axis. So if we put a point on our real imaginary plane, like -4 plus 3i, and with this point here, the absolute value of this will be the distance from this point to 0. If you think about it, that's really the hypotenuse to a triangle that's 4 across and 3 high, so that would be 5 using the Pythagorean theorem. -4 squared plus 3 squared is equal to 5 squared. That's the absolute value of my complex number z. Alright, so what is the absolute value of this point here, -2, -i? So if we use the Pythagorean theorem, -2 squared plus -1 squared, we get rad 5. Okay, so just some definitions here. R is the absolute value of z, my complex number, and we use the letter R to represent the radius, like on a unit circle from the center out to that point. The absolute value of z is equal to r, and then the horizontal component is the real part, the one that goes sideways, and then the imaginary part is the vertical component. Okay, so this would be just rad 26 if we were trying to find the absolute value of 1 plus 5i. Now if we want to write this in trig form, we have this point here. First, we have to find the absolute value. So the absolute value is going to be 2 squared plus 2 rad 3 squared. 2 times 2 is 4. 2 times rad 3 times 2 times rad 3 is 4 times rad 9, which is 4 times 3, which is 12. 12 plus 4 is 16. Taking the square root, I get 4. Now we find my angle. My reference angle is going to be the sine over cosine, so 2 rad 3 over 2, and that reduces to just rad 3. So if we take the arctangent of rad 3, we get, from looking at my unit circle, we get pi over 3. That's in radians. And since we're in quadrant 1, because both of these numbers are positive, the real and the imaginary are both positive, we're in quadrant 1, my theta is equal to my reference angle, which is just pi over 3. And then rewriting the whole thing, r times cis of pi over 3. You can write it either way. Some like it this way, I like it this way, but that's no big deal. All right, let's do some more. Before that, let's give you the formulas for all this. So this is all the formulas for it, so you can write that down if you want. And let's do this one. 6 minus 6i. So first we find the absolute value, which is rad 72 or 6 rad 2. Then taking the arctangent of -6 over 6, absolute value is just 1. And looking at my unit circle where tangent is 1 is at pi over 4. So now we are in quadrant 4 because we are going positive and then negative. We're going to the right and then down, which leaves me in quadrant 4. So I know that that's going to be 360 or 2 pi minus pi over 4. And that's going to be 8 pi over 4 minus pi over 4, which is 7 pi over 4. Putting it all together, we got 6 rad 2 cis 7 pi over 4. Okay, let's do another one. Z is equal to -1 minus rad 3I. You do this one, unpause this once you got it worked out. Okay, so I find my magnitude, which is 2. My reference angle is the arctangent of negative rad 3 over -1, which is rad 3, which is pi over 3 again. We're in quadrant 3, so we add that to 1 pi, or 180 degrees. And that's 3 pi over 3, which is 1 pi, plus my 1 pi over 3, it's 4 pi over 3. Putting all that together, I get 2 cis 4 pi over 3. On this one, I get 3 minus rad 3I. The magnitude is 2 rad 3. Pause this if you want to work it out yourself. Okay, if you have an answer, you can check it here. You can get rad 3, negative rad 3 over 3, absolute value. And then using the arctangent, we'll get pi over 6. We're in quadrant 4, so we're going to subtract that from 2 pi. Get a common denominator of 2 pi is 12 pi over 6. That's 11 pi over 6. All right. Okay, so that's it. You may want to try some of these problems in your book, especially like number 21, number 22, and 29, and 31. Okay, and you can check the answers in the back.